Hello guys, in today's session we will treat while loops. As you see here we have an example of a while loop. So we have some code, a previous code before while and an after code after while. So we have the keyword while, and inside the parentheses we need a condition to loop over, and inside the while we have the body. So until the condition will be false, then we will jump to the next code and continue executing the rest of instructions. So as you see here, it is I put an abstraction of our bytecode. As you see, we have a condition, then we need to emit a byte called object if false. You remember from past videos we treat that in if statements. So this, it will jump if the condition is false, it will jump outside the body of the while and continue executing the rest of instructions. And then we have body. The body could be anything, variable declaration, printing, another loop, everything you need or you put inside that body will be executed. So then I will introduce another bytecode called loop. This loop, it will jump backward to some bytecode. So as you see, we have loop, and when the VM executes bytecode by bytecode, if it sees a bytecode called loop, it will loop over to some instruction. So let's jump to the code and implement that. So let's go to our VM, our compiler.c, and change our grammar and add in statement. We will add while statement, and let's define that. While statement will be keyword while, and a left parent and a expression, then a closing parent and some statement. Inside that while, it could be statement like printing, expression, or block, or if statement, or another while statement for loops, for inner loops and something like that. So let's jump to implement that. So let's go to our statements, and here we will add some condition. Else if match token while, what we need to do is to call the while statement function. So let's go and implement that. So what we need to do is I will do static void while statement, and inside while statement I need to remember the location of the condition. Where is the condition? So it's where is the start point of our loop. So I will read the count of bytecode we have on the chunk. So that is the location of our loop start. So then I will consume token left parent, and I will raise an error. If not, expect left parent after while, and then I will call expression, this for the condition part, and then I will consume the token right parent. I will raise an error if not, expect left parent after condition. So then I need to emit the up jump if false, so I need the jump offset, emit jump up jump if false, or let's name it exit jump, because that it help us exit the while loop. So this bytecode it help us exit the while loop, so we'll name it exit jump. So after that I need to emit byte up just to free the value of the condition from the stack, and then I will call statement to treat the body of the while body. So what I need to do also, I need to emit loop, and I will give it the start of the loop. We will define that function emit loop. So what I need to do is to back patching, call back patching function on exit jump. Remember that function from previous video, we use it in conditional branching, if statement and else statement. It helps us to back patch the address to know where to execute the next instruction, or what's the next, what are the steps that we need to jump over many instructions to find the appropriate instruction. So finally I will emit byte up in case we exit the loop. The condition is still, the expression of condition is still on stack, so I need to pop it from the stack. So let's go and define the function emit loop, static void emit loop, and we need the offset we need the loop star, the position of the star of our loop, which means the position where the condition is star. So I will first of all emit byte up, and then I will prepare the offset. The offset is current chunk minus plus 2 minus loop star, and then if offset is greater than the maximum of 2 bytes, that means we'll raise an error, loop body is too large, and then we will emit 2 bytes. The first byte we will shift to the right the offset by 8. It's the same as the if condition and else conditions, and we do the logical AND on x value ff, and then I will emit another byte. We'll do the AND, and that's it for emit loop. So what we need to do, excuse me, here I made a mistake. It's not up, it's up loop. Okay, so which reach that condition. Okay, as you see, which reach the condition. Then I need to emit object if false. Okay, I emit that with pop, just to pop the condition from the stack. And I need to treat body. The body is treated by statement function. Okay, I treat that. Then I need to emit an opcode called oploop with its offset, and that offset we will define it in the function emit loop. So as you see here, we emit loop, and I give it the position of the condition. Then what I need, I emit the loop, and then I calculate the offset, and then I emit the 2-byte address of the offset, and finally I backpatch the exit jump for that. After I emit that, I need to backpatch that to see where we need to point, and then I emit a byte for freeing the stack from the value. Okay, so let's jump to the chunk to add that opcode. So let's do it. So let's go to chunk.h and we'll add op loop. That's good. And let's go to debug.c, and what we need to do here is to add to jump instruction function, add a value, another parameter called sign. If the sign is positive, that means we have some operation that point to backward instruction. So if they have the sign negative, which means that the opcode will point to some previous instruction. So in loop we point something that is previous, not like object if false, it points to something advanced. So we need to treat that. So what I need to do is to add the tree here, and I will multiply that offset with the sign. So in case of false, we have something forward, so I will pass 1 plus 1. In case also for jump is something forward, but for something like op loop that point to something backward, I need to jump, call the jump instruction, but on a negative value. Up loop pass chunk, also -1 and offset. So that's good. So let's jump to VM to interpret that. So I will go after case of loop, and what we need to do is to get the offset by using the macro rechart. And what I need to do, VM IP, will update it by negative offset. Will subtract the value of offset from the IP because the IP need to go back. So, and I will do a break. So that's it. So let's go and recompile our project and see if we have any issues. So we have an issue here, get current chunk. Okay, I need to go to that compiler.c, get current chunk. I need the count of that. So everything is good. So let's create a simple program. So we need I will print the numbers from 1 to 10 while, so let's initialize a value x equal 1, and if x is smaller or equal than 10, we will loop over that until the condition will be false. So I will do print x, and we will increment that by 1. So let's test that, and let's see the bytecode of that. Okay, we forgot to put the semicolon, so let's clear that, and let's do that another time. So okay, let's see the bytecode. As you see here, we have that. This is the bytecode. So for the first thing is just a simple instruction to print a string. It's normal. So here we have just a declaration of the value 1, okay, variable x, and here we get the value, the global value, and we test it by the value of 10 if it is greater, and we do not. So we have the main thing is to jump to 31 if false. If the state of our stack has a value false, we will jump to 31 instruction and it's pop. That's good. So if the instruction is true, the condition is true, we will pop, and we will get the global value and print it, and then we will get the global value, and we will load to stack value 1, and we do addition, and then set the global is the assignment instruction, and then we will pop, and then we will loop over, and we will jump from this instruction to the instruction 7, and the instruction 7 is the condition. Okay, from here it starts the condition. We will get to the value, the global value, and we load to stack 10, and we do a comparison between that, and we check if false, and we jump if that false. As you see, we have successfully implemented that instruction of code loop that go backward to some instruction and from the condition, and continue executing until the value is false, and it will exit the while loop and halt the machine. So let's see the state of the stack. So here is just a definition. So let's see the condition. We load 1, we load 10, and we do comparison. So we check if that false. So 1 is less or equal than 10. It's true. We will not jump to the instruction 31. We will continue. We will pop, and then we will print, and then we will assign the value to be 2. We increment the previous value by 1. So we go to that loop, and we will jump to instruction 7, and as you see, we are in instruction 7. We do the same thing, the condition. We load to stack the value of the global value x2, and we load to stack 10, and we do comparison, and it's still true, and we will not jump to the instruction 31, and we continue. We print that, and we increment that by 1, 3, and we have an instruction loop, and we go to instruction 7, and as you see, we load the condition, we load 3, and we load 10, and we compare that, and we check if that falls, and so on, and that is repetitive. So let's go to the final one where the instruction is false, the condition is false. as you see, it's here. So we print 10. So the condition, okay. Now we increment that by 1. We have 11, and we still loop over to the instruction 7, and we load to the stack the final value 11 and also 10, and we do comparison, and voila, we have false. So we will jump if false, so the state of stack is false. So what we need to do is to go to 31 instruction, we will pop and we will continue until we halt the machine. So guys, that's good for now. So let's go to command.h and deactivate these two for debugging and printing bytecodes. So what I need to do is make all from 0. I will clear that, and I will cat the example, and I will run that on sample. So as you see, number from 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So guys, we have accomplished something really good. We've accomplished the while statement. It's a useful instructions that loop over some instructions that need to be executed many times until some condition is false. So guys, our Ant language is capable to do conditional branching, if else statement, and also loop instructions like while. So see you guys in another session.